registration for 1,000.
Registration 1,000.
Oh my God. So
First come, first join.
criteria, the sooner the better. I mean, who gets first gets inside.
Yes.
I see, I see. Okay, so I think it's 5 minutes past 11. If you like, I think we can start.
Yeah. Thank you, President.
Thank you.
Good afternoon, everybody. Good morning, everybody. Uh, I welcome all the participants who have joined this webinar organized by ICID. It's a webinar in a series titled Smart Irrigation Management. And we have sixth webinar today. And this webinar title is Bringing Together Technology, Innovation, and People to Enhance Water Efficiency. And this will be delivered by L&T professionals. And the speakers will be Mr. S. Dev Anand. He is head in large water system units in L&T. And he will be joined by different officials from L&T in his presentation. So I welcome President Marco Arcieri, who has joined this webinar, and all other participants. And now I request our President, Dr. Marco Arcieri, to give an address before we start this seminar.
Thank you. Thank you very much, Secretary General, and thank you very much, colleagues from ICID Center Office, for this excellent job you're running, you're carrying out. I see, and good morning, and thank you to all the presenter, Mr. Devanan, Mr. Karbanda, thank you for, and all the others, thank you for Mrs. Diana, thank you for your willingness and your contribution to this very important, very interesting webinar. I have only one or two considerations before we start. First of all, I see that our webinar are getting more and more participated. Hundreds of people. As of now, today we have almost 500 people, and which is the maximum capacity, and we had registration for 1,000 people. So this is very encouraging, and it's very rewarding, I might say, for us as ICID, because shows that people want to participate. There is a need to share knowledge, which is one of our goals as ICID, and there is a need to listen, to be updated, provided that the contributions and the information that is provided by means of our webinar is updated and is technologically and scientifically at the level. So this is why I'm very grateful to presenters and the organizers, Central Office, Secretary General particularly. Second consideration, very quickly, we are dealing today with this theme, which is rounded about bringing together technology, innovation, and people to enhance water efficiency, water use efficiency. Of course, we are talking about technology, so we will be describing, our presenters will be describing which are the modern tools which allow for precise monitoring and management of water resources, which means, for instance, the use of artificial intelligence, remote sensing, data analytics, and so on. So the great power we have today is to use satellite imagery and sensor to track the water level and the health of the crops at any given time in real time. This is very innovative and open really a new frontier for agriculture and for smart irrigation. And of course, talking about smart irrigation, we have the possibility to introduce new automated systems, automatically regulated gates, which give water to plants only when effectively necessary, probably uh, regulated by the demand coming from the crops. So I'm talking also of advice, irrigation scheduling, irrigation advice, in order to reduce waste of water and increase productivity. And of course, there's the second pillar of this webinar that we will be dealing with is regarding the strategy, the innovation. We have to think also of new sustainable practices because water we know will not be there forever. So we need to create tools that can be modular and scalable to fit diverse climates. We have to adapt a shift of the paradigm of the policies, implementing, for instance, adaptive management frameworks that can respond to climate change increasing and to the increasing water scarcity. And last but not least, of course, the people. So the people are those who will take action. And this is a critical element because technology only works if it is adapted correctly. As we used to say in the scientific community, you cannot manage what you cannot measure. So you need to have a very good level of involved stakeholders. You have to engage farmers, researchers, and policymakers all together to ensure that technology really is meeting the world needs. And of course, really last consideration about capacity building. Capacity building is one of the core business of ICID, training as well as knowledge sharing. So we have to strive, we have to foster for awareness, providing training at all levels, local level, rural communities, in order that they can become owner and ruler of their own management practices. So integrating all these three elements, people, strategy of innovation, and technology, I think it is possible to really to reach a resilient, equitable, and sustainable water use, not only for us but for the generations to come. Thank you very much. So I'll give the floor now to Secretary General. You have the floor and the word for introducing our presenters. Thank you very much.
Thank you, President. Before we go for the webinar, I would like to show the flyer for the next webinar, which we will be having on 22nd of May. Is the flyer visible to all?
Yes, I can see it. Yes.
So our next webinar topic is precision water resource management in irrigation, intelligent sensing and modeling. And this will be given by Professor Dr. Attila Nagy from University of Debrecen, Hungary. So the time will be same, 14:30 hours IST. I have now a request to all the participants that if they have any question, they can write this question either in the chat box or question answer box. And I will request our presenters that after the presentation, if they have time, that then they can answer few of these questions. And if some questions are remaining, then they can answer these questions through email also. So participants can write their email also in the chat box. And I will request the presenters also to give their email at the end of the presentation so that all the participants can ask if they have some questions in their mind later on also. So now I request our presenter today, Mr. S. Devanand, Head Business Unit, Large Water Systems of L&T, to start the presentation. Mr. Devanand, the floor is yours.
Thank you. Thank you very much, sir. Ladies and gentlemen, at the outset, I would like to thank ICID for giving us this prestigious platform to share our experience in Kundalia Irrigation Project as an implementation agency. Heartfelt gratitude to ICID President Dr. Marco and Secretary General Dr. Gupta, and special thanks to Mr. Vijay Sharan, Director, who's initiated and coordinated for the webinar events. I am Devanand, representing Larsen & Toubro, an Indian multinational organization operating in over 550 countries, especially in EPC project, high-tech manufacturing and engineering service. As an organization deeply committed to national building, we take immense pride in our contribution to water infrastructure, particularly in irrigation, where we have played a role in enabling irrigation infrastructure that serves over 16 lakh hectares. Our extended sincere thanks to the government of Madhya Pradesh for entrusting us with the prestigious Moganpura Kundalia Model Smart Irrigation Project. It has been an honor to be associated with the project, such an important for water conservation. The success of this initiative is rooted in clear and forward-thinking vision to ensure water reaches every single hectare through an efficient rotational distribution mechanism. We would like to acknowledge the efforts of the officer involved, with the special mention Mr. Rajoria and Mr. Shubhankar, who were there from the conceptualization to success completion. Normally, in any government department, it will not happen. The person who's starting, he may not close. But here, the advantage of that it has been there. Why the project became a model? Since it is not just innovation or the use of advanced technology, but the active involvement of end user. By actively engaging farmer through a participation and collaboration, the project has established a sustainable approach to water conservation and effective utilization. This is more than infrastructure achievement. It is a people-driven success story demonstrating how collective efforts and shared responsibility can transform the way we manage our most precious resources. To start with, I want to relate why the conservation is more important, what water is precision now. We have gone through that data now. Last 2 years, I have taken it only. Horn of Africa, where 36 million people are suffering for drought, where water is not available. Amazon forest and South America, it is having a lowest water level in over centuries. Our neighbor Pakistan had a heavy flood and also the heat waves. It is affecting environment. So now in India, how we are going to manage things. So in 18% of population of world, but we are having only 4% of water resource. Historically, per capita water availability in India was about 5,000 cubic meters per year in 1951 statistics, which now has reduced to around 1,500 only. The international acceptance of water stress threshold, it is 1,700 cubic meters per capita per year, which India has already crossed. So it is clear that we're living in the age of water emergency. This slide shows on Indian context 2025, if you see the already maximum places in water scare. So when you're comparing to 2050, it is going to be further. Even we are going to face a acute water shortage. Even the water balancing, we can able to have the new initiatives of river water linking. We can able to manage available balance, but however, we need to have huge focus to be given for water conservation, like Kundalia projects. Yes, the need of our is not just creating water infrastructure, but also ensuring its conservation and efficient use. India is more focusing on, even I can taken the reference for last 10, 12 years, what all the infrastructure it has been made for balancing the water and safeguard the future. A lot of barrages, dam constructions have been started. Now barrages been constructed to store the water and channelizing for wherever it is required. The water normally will be using the gravity. We'll have the canal system. And from the canal, now it is been there minor and subminors. Even the open canal lift irrigation, the combination of pressurized pipe and high elevated place through aqueducts and moving waters. There are some projects which is having now constructing the elevated places we are having a storage facility. From there, water has been distributed to the high level areas. The more focus and attention is being given open canal and combination with piped network, pressurized pipe network. When it is coming to water conservation, that is using up to command area, more focus has been given. In that, the lifting, the pressurized lifting system, where we are providing that even the smart irrigation like Kundalia, it is now in the form. There are command area developments also, it has happened, where the earlier water has been transported only by the canal, then it is piped network. Even up to field 40 to 20 hectares water has been given, where the encouraged to it is flow irrigation. Then the next development it's happened up to reaching 4 hectares, it has been given. Now in Kundalia, we brought the broader up to 1 hectare. That is also micro irrigation. It has become possible. The future is definitely precision irrigation, remote sensing, and DSS, which is even the Kundalia, it's having a provision to execute it, including ICID and the government mission of India, improve on farm water user efficiency and sustainable water conservation practice, expand cultivatable area, precision irrigation and water saving technology. All it is in one project. That is what Kundalia irrigation projects. Now it is not possible also. This project is made possible, and that is what the future of Indian irrigation practices. Here, this taking forward this vision to MP State Water Resource joined hand with ADB and give us the responsibility to implement the project to provide 130,000 hectares, including the design, procurement, construction, and operation. The project has been successfully completed and it is in use, and people are getting benefit last 3 years. The project has achieved many milestones in water user efficiency and has many unique features. During the presentation, if you have any queries, you can comment with your email ID so we can able to respond to you. From here, I'll hand over to Mr. Dinesh Karbanda, who is fully devoted in this project from the day zero, will take over the presentation to the project details. Over to you, DK.
Yeah, thank you, sir. Thank you. So, I'm Dinesh Karbanda. I got the opportunity to join with this project since the date of signing of the agreement. So it was a pleasure journey, and I hope that now we will have a pleasant virtual tour of this project. And this project, as told SDSR, also achieved many milestones in the water use efficiency, and I think the points highlighted by President in his opening remarks, maximum of the things we have initiated in this project, and definitely we will go through to take it to new heights and take new modern techniques also in this project. Now, as we have seen that lift irrigation is not a new thing. It was started way back with the target to lift the water to higher altitude, and then open canals were used to reach to make water reach up to the farming land. Then later on, to improve the efficiency, pipe distribution network is integrated to this lift irrigation, and where initially it was to the territory of the open canal system, branches of the open canal converted into the pipe distribution network to make the water reach up to the last milestone of the farming land. But then in Monpura Kundalia model, basically along with the Kundalia, one scheme is running is the Monpura. As a combined together in this scheme, target has been made to improve the water use efficiency to the higher level possible. And in this system, complete from the lifting to the last end of the farming land, that is up to 1 hectare, water is being delivered through the pipe system. And there is another smart irrigation systems are possible in this, which through which up to last stage it is in a controlled manner water is reaching, and as per the farmer requirement it is reaching. So why we have gone for that? In normally, if we see that project efficiency, which is getting measured in terms of the how water, every drop of water is utilized to grow the crop. So in that term, earlier open canal system, India national average efficiency of India is the 38% presently, and with the all possible mean also we can take it up to the 64% maximum, because it depends upon the lot of things. If we are seeing reservoir, conveyance system, distribution system, then at the farming land how water is being used, and then how drainage is there for the excess water. So I'll depend upon that. In open canal system we are having very limited control to control these factors, but if we convert this system into the pipe irrigation, pressurized pipe irrigation, then we are having the better control over the conveyance, distribution and water use, and drainage. If we are going for the micro irrigation, then drainage is also not a question in that. So in that way, with those things, we can go up to the efficiency of 90%. And I am pleased to tell that in last season also, what we measured that we have reached up to the 80% of the water use efficiency in Kundalia. And why this efficiency matter? In if we see in the India, total 89% of the water consumption is there in the agriculture. Even a 1% improvement in the agriculture sector efficiency, it will yield more scope for the future, more use for the industry availability of water. As and everyone told that ki water is the day by day it is becoming a precious resource which cannot be created. It only with the available water we have to grow. So in that way, efficiency is much more important in the irrigation sector, and there is a huge scope. And now in coming to MP, if we are seeing that water use efficiency as compared to national, already it is 43 to 48% with the open canal system. Now, the way back in the 2015-18, between that period, state has set up the target to make it double almost. So they have set the target 75 to 80%, where then team of MKPMU has come into the picture and they have designed this project where they have taken that from the resource to the last root level. They have converted complete irrigation network into pressurized and through pipeline. And in this project, we are delivering water up to the 1 hectare, which is almost at the last end of the farming area. Now, if we are seeing that the open canal system, with open canal system, it is possible that with 1 MCM, we can irrigate 170 to 225 hectare. Then when this Kundalia irrigation project is finalized, their target has been kept for the irrigation of the 275 hectare. But in the last now, since 3 years, we are running the water, and we have observed that this with 1 MCM, we are able to irrigate 425 to 450 hectare, which is almost double the open canal system. So, which is a good use of water, available water, and we are irrigating much more area than which is possible with the open canal system. Now, in this project, total Kundalia irrigation project is designed to irrigate 1,39,600 hectare area, and it is covering 2 districts of the Madhya Pradesh. One is the Agar Malwa and other is the Rajgarh. And the dam which was constructed as a part of this project is having a storage of 583 MCM water. Now, this is a typical view how this model is working, and schematic of one section of this project, that is Kundalia right bank, and it is covering 67,091 hectare area of Rajgarh district. And under this scheme, we are lifting the water from the dam backwater through we are tapping the water through a approach channel of 2.5 kilometer, which is an open channel. That is the only open area in this project. Then pump house is constructed. So from the pump house, we are lifting the water to the 3 DCs. Why 3 DC, not a single DC? Because there is another challenge in the irrigation, lift irrigation scheme is the power. And power we should be optimum use of power need to be ensured. So as the area, no area is the plain area. It is having different topography, different terrain. So based on that, we have divided into the 3 zones, so that according to the zone requirement, we are lifting the water up to the desired height. So up to 84.5 meter in the DC1, then in the DC2A, 2B, we are lifting the water up to 114 meter height. There over the hill, we have constructed the DC, which is providing the water by under gravity, pressurized water under gravity. That is another unique feature of this scheme. So in that way, water is reaching to the 1 hectare. And to make it possible, there is a pipeline network combined together in Kundalia irrigation project. We have laid more than 14,000 kilometers of pipeline network. Believe it, it is like a veins in the body. Water is traveling underground to the farming area like blood is flowing in our body. Then there is a power requirement was there. So we are having a 132 by 11.5 kV switchyard, and installed capacity for this here in right bank is the 40 megawatt, and in the left bank scheme it is 30 megawatt. We are tapping the 132 kV from 220 kV substation, and then power is reaching to the headworks, from where with the VT pumps we are lifting the water. So this is a typical scheme and how it works. Now, with all this arrangement, what unique features we are having in Kundalia project? First, already explained that the pressurized irrigation network with micro irrigation enabled, that our system is completely designed where micro irrigation can be used effectively. When we are using micro irrigation, then to ensure that farmers should not have much problem, then so for that purpose, we are having multi-level water filtration. So that is going to be explained in subsequent slide how these all features work. Then distribution system is also made smart so that every drop of water which we are pumping from the pump house should reach to the last milestone of the 1 hectare. So in between, to have the control and those things, we have made this system as a smart distribution system. Complete this distribution system is operated automatically, and with this SCADA integration is there, where all the parameters are getting recorded, which can be used for the future development purpose also, and can be monitored effectively. Then to ensure that scheme should deliver and result effectively, farmer participation is also ensured in this scheme. Equal weightage to the technology has been given to the farmer participation. For that also we have taken various steps in that. And then there is a sustainable, to make this system sustainable, high efficiency, that is integration of technology, innovation, and people has been made, so that scheme should be sustainable and it should be delivered with the best possible efficiency in this sector. Now, I am going to explain this component-wise things. So as told, that complete system is pressurized irrigation network, and it is working completely based on the gravity. That is the unique feature. So in between, because of the gravity, we are having a lot of advantage in controlling our distribution network. And then at the last milestone of the 1 hectare, we are delivering the water at the rate 4.5 liter per second with the 20-meter head, so that pressurized water can be used for the micro irrigation tools. Then all the distribution chamber are also designed with a 30 minutes retention time, which provide us the better control during the irrigation season when there is a fluctuation in demand is there, daytime different demand is there, night different demand is there. Though this complete system is possible with the regular 3-second or 3-minute retention time also, water can reach effectively at the farming land. But to have the better control, which PLC and SCADA can provide us to control the fluctuating demand, for that purpose, we have gone with the 30 minutes retention time here. So for this purpose, normally we are constructing to make the gravity-based system. Over the hill, we are constructing the distribution chamber. But in the Agar area, where comparatively flat land area is there we were not having the this hill rock where we can construct our desired capacity distribution chamber. So we have used the RCC framework to make it as a elevated water storage tank, which is one of the Asia's largest tank. Its capacity is 26,958 cubic meter capacity water storage over a height of 32 meter. So it is also a very big structure which has been made to meet out the end result of making pressurized under gravity. Now, I told you that for micro irrigation, it is necessary that system should not have the turbidity and water should be the clean water should reach there so that choking issues should not come in the micro irrigation. For that, here 3-level filtration system has been kept in the system. First is our trash rack, which we have provided with the mechanical grab cleaner mechanism at the pumping station. It is installed at the sump inlet. For all the individual pump bay, we are having one screen. So here it is screen spacing is the 50 mm. So it control all the debris and floating material which are coming in through the river to the sump. It got arrested here, and then mechanical grab cleaner is there so that it can be cleaned with the minimum efforts. So that is the first level filtration. Then after pumping, our all system is going through the primary filters. That is where mechanical screen is there of the 200 micron. Up to with that 200 micron filtration is happening there, and system is having the additional feature of the auto backwash. No one need to clean on, by stopping the system. It is online mechanical backwash system is there, which is automatically triggered once there is a delta P, means the difference in inlet and outlet pressure of filters are there. So there it is getting cleaned automatically without stopping the system. Then there is the third level filtration is also kept, which is at the last our OMS box, outlet management box, which we have installed at every 30 hectare. There again filtration screen is there of 150 micron, so that if due to any system issues or anything, if any impurity get added, then also it should be clean before it reaching to the 1 hectare outlet. So in that way, it is system quite efficient, effective for making it enable for the micro irrigation. And then, unless we measure, things will not control. So whatever precious resource is there, water, so we have kept the system to measure it at number of levels in the distribution network, which I told initially also at the smart distribution network. So it is having, because of these features, we have remote management system, which we oftenly called as a rotational management system also, which we have installed at every 300 hectare. With this, we can, without going into the field, we can control the flow. And this remote RMS is having certain more features, which will be explained in the subsequent slide. But we are having first control in distribution network at 300 hectare. Then outlet management system is installed at every 30 hectare. There we are having the facility to measure up to all the flow and pressure at every 5 hectare subject. Then air valves are the common things which we are using in our distribution network. It is necessary for making it functional, but we have converted it into as an additional monitoring tool also. We are measuring pressure also along at all the air valves wherever we have installed. We have installed the pressure sensor there, which is giving us the pressure for all the network, distribution network at the more number of points. Oftenly, it is installed at on an average at every 1 kilometer at average. So then to make the communication, we are using the LoRa gateway towers, which is working on the radio frequency. System is working through that, and all the data are going to the web SCADA for further operation. And then there are the certain other features. As I told that, we have kept the 132 by 11 kV switchyard at the site itself to have the dedicated power for our system. Power is the critical resource. So we are having this 132 by 11 kV switchyard at site, which is having dedicated line from a 220 kV switchyard. And to maintain the power factor in this, we have installed the capacitor bank to maintain the power factor above 0.95. That is also where we are getting the incentive. Then additional VFDs has been installed. Every motor is having the variable frequency drive. So with that also we can control the fluctuating demand with the good efficiency and and for healthiness of equipment is also good with the use of the VFD. Then to make the system cool, because lot of control and those things are there, sensitive instruments are there. For cooling purpose, we are having the air handling units, which is supplying cool air in the VFD rooms. Instead of the conventional air conditioner, we have gone with the air handling unit, which provide the energy efficiency in the project. Then workshop building is there, where all the things can be minor repairs or whatever things are there, because irrigation projects are in the remote area. These projects are not in near to the city where we are having the fabrication facilities or repair facilities. So we have kept one workshop building where vendors can come. If any issue comes, they can repair at the site itself. As we are lifting the water up to a 114-meter height, there is a chance of water hammer also there. To arrest that, we have installed the surge vessels there, and which is the bladder vessels. Balloon type arrangements are there in that to control the surge. And then complete system is monitoring through the SCADA, and all the command area is developed over the Google Map, and it is maintained through the web SCADA. Now this is just a scheme which we are showing how the pumps are starting in the auto mode. Let's start. So once we are giving a single command of the start, complete network is taken over by the PLC. And then it do the initially pre-check, then it start opening the first HOPD bypass valve opening. Then it gives the command to VFD to make motor run. VFD initially start the motor at low speed. And then once the pressure transmitter gives the proper pressure reading, then it go on the final RPM. Then individual line is having the flow meter, which is giving the flow. So we are having the online instant monitoring through flow meter and pressure transmitter for the pump. And in this way, with a single command, complete system is running over the PLC mode. No manual intervention is there. So certain further control measures are there, which I will explain in the subsequent slide. Now, this is this live screenshot which we are having for our pumping system. All the 40 pumps installed, 11 working, 3 standby. 11 pumps are working, which is denoted by the green color. Then continuous monitoring of the inlet approach channel side water level is also there on the left side of these pumps, and on the right side we are continuously getting the water level of the DC, all the 3 DC, and all the limits are set up to what level alarm will initiate through SCADA, and at what level, if no action has been taken manually to control the supply or that, then system will, once it's reached to overflow level, complete system will get automatically stopped through the PLC preset commands. No manual intervention is needed. Then this is the schematic of the one particular DC network which we are getting on the live on our control room. So there it is for the DC1 of the right bank, where 3 pumps are working and 1 standby pump is there. So we are getting live pressure, flow meter reading, and then another thing, top of the screen you are seeing that turbidity is also getting monitored online, which is showing 0.91 NTU, means it is good for the pumping further. And then primary filtration system is taking care of the rest of the turbidity level to reduce it. And then online header pressure is getting monitored, and then water is going through to the DC where live DC level is appearing. Now, in this SCADA, which I am telling that why human intervention is minimum needed and it take care of all, it is because the critical parameters, we have kept the sensor for vibration, sensor for temperature, bearing temperature is getting monitored, current is getting monitored live, and all are having the preset levels. If any level is going out first, hooter will give the alarm to the operator to become alert that something is going on, and if reach the trip point, it will trip the system so that no damage to the system should come. So always that all the critical parameters are getting monitored through our SCADA. Then this is the communication. Communication is very important because in the field, if we have to control the distribution network, which is of 14,000 kilometers, so it cannot be controlled without communication. We cannot have the number of person in at every field to give us the alert and those things. So how it communicate? OMS or AMS or RMS. They are communicating to the LoRa gateways, which has been installed at the suitable point in the area. And then LoRa gateways are communicating to the cloud server through the GPRS, means GSM base. Then cloud server can be accessed through internet, through the mobile app, through the regular LAN network at our control room. So with that, all the live data we are getting for the distribution network at the control center. With the set username and password access, we can access it from anywhere of the world where internet is available. So complete system is designed like that. Now this is the RMS. Which is installed at every 300 to 500 hectare on average. It is monitoring this RMS. Upstream side also it is monitoring pressure, and downstream side also. Then there is a preset sustaining pressure, reducing pressure, and set flow is there. We have set the sustaining pressure, which is denoting the lower pressure, which is given as a 15 meter in the terms of the head. And then upper limit we have set for this particular node as 60 meter. So between 15 to 60 meter, because that limit has been set based on our DC water level. DC is having the huge height. So there is at the minimum level pressure will be less, and when it reach at the upper overflow level, that time pressure will be more. So in that range, flow will get vary, as if the pressure is less, and based on that velocity will get affect. And to have the uniform flow over the RMS, that automatic flow set point has been kept. It will deliver 77.33 LPS to the downstream. It is adjustable for the different RMS. Why it has been kept? Again, for the topography is different. Some areas are at lower level, some area are at upper level. So to maintain the uniformity of flow based on the area that distribution line covered, we are using this RMS, where set flow rate we are having, and then it adjusts its opening position based on the pressure. What pressure it is, it can work on that. Good. Then another control we are having at the 30 hectare OMS. This is typical of, this is the heart of the project, outlet management system, which we have installed at 30 hectare, which provide lot of unique thing for a rotation, and a schedule based water delivery to the farming land as per requirement. In this is we have installed at 30 hectare, and it is having the 6 outlet. 6 outlet means at 30 divided by 6, it means 5 hectare. 5 hectare we are calling as a subject. So at a time, 3 subject we are providing the water. Means at a time, 3 hectare people can get the water. 3 outlet can be open. 5 hectare subject we are having the pressure and flow control. And this 5 hectare divided into 1 hectare. And that control is only manual control, which farmers, as per their requirement, they are opening manually. So under this OMS, also set pressure is there, set flow is there. Based on that, it PFMCD get its position set automatically as per the pressure and flow coming from their upstream. So this is another AMS which I talked at. Air valve also we have made it as a smart unit, and we are calling as the air management system. We are not calling as a air valve. We are naming it as air management system. So this is installed at the based on the level, topographical level, that at the every higher level where line is getting crossed, we have installed one air valve and we are monitoring the pressure. So this unit is used to identify the leakage in the network. So if anywhere sudden drop is pressure is coming, so immediately alert is coming through web SCADA to our control room that some issue is there. Either it close the RMS of that branch network, or if not possible, then manual valves are also there. Then instruction will go to our farmer relationship officer, FRO, to control the manually that. No need that if someone see the leakage and then report, but our system through air management system, it automatically alert are coming into the network to identify the leakage in the network. Now, this is what I was calling that key OMS, which is our heart of the project. It provides to control the water delivery from a remote location. This unit is the operable from anywhere where internet connection is there. It is having the solar power inbuilt. solar panel chargers are kept in this work on solar power, and through LoRa network, it communicates the command to the field. If because the scheduling is must, in a particular chuck, all are not growing same crop. Some are making it different crops, different water requirements. So this system give us the flexibility to schedule the water as per farmer requirement. So if we are, as I told that in one click, we are giving the 3 chuck. So uh, when we are clicking first, then in the first way, it is delivering the water to A1, B1, C1, like that. It is a adjustable scheduling. It is not a fixed one. I am showing a typical, because why adjustment is needed in this crop. When we are sowing in a field, based on its crop stage, different type of water requirement is there. Sometimes it need a 8-hour shift, sometimes it need a 3-hour shift also. Sometimes it need at the initial phase before sowing, like here locally called pleva, that time it need a huge water. Then scheduling is needed for a 12 hours. So as per the crop different stage, we are making the adjustment in the OMS scheduling. So in first go, it is giving first shift, it is giving A1, B1, C1. Then in next shift, it is giving B1, E1, F1. Why we are keeping the different outlets? So that whatever micro irrigation tool, if community irrigation system is getting developed, they can shift the sprinkler from the A1 to A2 in that period when D1, E1, F1 is getting water. So in that shift, they are shifting the sprinkler set or micro irrigation tool to the another chuck. And in this way, in a 10 shift, we are covering the total 30 hectare OMS chuck. So scheduling is adjustable as per intelligent scheduling, or based on the chuck committee recommendation, we are adjusting the schedule. But total 10 shifts are needed to cover a complete 30 hectare chuck. That can be in the 10 days also, and those 10 shifts can be in the 3 days period also, based on depending upon the crop age. So now, this is the what we did so far in the Kundalia, but there is a way forward is also there, which we are seeing, and already President has also told in their opening remarks that system is need to be integrated with the satellite, and then Earth receiving stations can be there, which can communicate to the web SCADA for all the parameters of the farming land. Okay, how it works. We like with the satellite itself, we can measure the soil moisture, and we can calculate the what soil moisture present is there based on the through the decision support system, which is having the preset what was the soil moisture day before, then what rain or anything has happened, then precipitation it can calculate, and what irrigation water we have given to that particular in that period, minus evaporation loss. Then it give us the soil moisture present in the soil particular chuck. Then if requirement, soil moisture required at that age of the crop is less than the moisture level of soil, automatically irrigation can be triggered. Same is vice versa. Otherwise, if not required, already sufficient moisture is there, irrigation will not trigger. Even means ki no scheduling effort is also needed. That is also possible with this system, and further innovations are going on, and already in ICID has also taken those steps. I attended last webinar also, which was related to this only. Dr. Veem has explained very well how satellite can be integrated with this type of irrigation infrastructure. So just now I am showing how in future of irrigation is there. Automatically through satellite signals will go what is where water stressed crops are there. Then those communication will happen to the cloud server. Cloud server will give the command to the mobile app to through gateway to the OMS to start the irrigation. Like we are seeing under the OMS2, irrigation is started based on uh, our this input command, automatically input command. No human intervention is needed. Means farmers can relax by just sowing in their field. Rest irrigation network will be taken care through the intelligent DSS system, which is the future which we are seeing is going to be happen in this area. So now I already talked about the technology as well as the innovations are going on in this sector. But is anything possible without people? Absolutely no. Already President has also addressed in his opening remarks. People are the key area. Whatever we will do, if people will not accept that thing, nothing is going to come. All things will remain on the paper only. Real water use efficiency can come with the people only. So in this project, we have tried to pay proper attention over this critical factor also. We have created the infrastructure. We have developed the farmer service center where farmer interactions can happen. Then demo farms has been developed, which we have named as the farmer field school. It is basically a school. School is not only in the to the students. It can be for anyone, because if advanced technique has to be knowledge has to be given, it should be given in the field. That is our principal concept. Then awareness programs we are conducting uh, at the local village level. Then in those FSC which we have constructed, regular agriculture training programs are being conducted through various scientists and experts. Then exposure visits also we are making for the farmer to see the infrastructure which we have created to the other advanced part of the country also. Then all the OMS, RMS we are handing over to the farmer himself, to a Chuck committee. Now, this FSC, which I was talking, that these 8 numbers we have installed, we have constructed in our command area. On an average, it is at every 15,000 hectare area, where we are providing the training to strengthen the farmer capacity. Capacity building we are doing in this project through the system. And then trainings we are providing. Then we are having the collaboration with the existing agriculture department and Krishi Vigyan Kendra, normally known as KVK in India, where expert scientists are there who are giving the training to the farmer about the new type of crops, new type of seeds, which are possible with this pressurized irrigation network. And then we are calling the local representative also, because people are listening more to the local leaders than to the engineers. So in that way, we are having the association, and they are themselves are coming, because it is best for them to convey the message to the farmer for their development. In so far this project, we have given we have conducted more than 2,000 trainings in this project so far, where we have already covered more than 30,000 farmers. And this process is continuous. We are giving on the different type of trainings to the farmer, whether it's related to micro irrigation, whether it's related to control of theft and damage, which are normally happening in this type of infrastructure, and whether it's related to making them aware about the scheduling. For that purpose, check committee meetings are being conducted in field. Then advanced training through the agriculture expert we are conducting for the crop production, organic farmer, and improved water management topic. These are some of the picks how we are giving to the initial level. We have given the training about the project awareness. These are the initial level training which we have given to the farmer, to making them aware about the project itself. Because when you have to give training and about this new type of project, it cannot be happen in a single day. So once we have started constructing the infrastructure in the field, at that time itself, we have started we have conducted the awareness program among the farmers. This is the future. You are going to get the water in this way, so that it helped us to create their mindset acceptance for this project. Then these are some of training programs picks through agriculture experts and scientists from the KVK and from all around the country. We are calling them to give the awareness to the farmers. Then these are the Chuck committee meetings which we are conducting with the elected member of the Chuck. We are making one Chuck leader and then certain Jal Mitra who are taking care of this OMS box at their level. And there only we are briefing them about the scheduling also, how best they can make use of this water with the common understanding among themselves. And then officially also we are making handing over type arrangement. We are making the agreement with the farmers that maintenance part related to the long term will be taken care by us, but regular operation maintenance, and if any things are scheduling, they have to make, how to communicate with the control room, what are the helpline numbers are there. In that, all things are written way we are giving to the farmer and making a common agreement with them. We will ensure the water supply, and they have to make the scheduling requirement among themselves by sitting at a common platform and conveying to us through their check leader. Those type of things we are mentioning in the agreement, and in a written form we are giving to the farmer, which gives them also a sense of ownership for this infrastructure. Then, as I told initially about the demo farm. So demo farm, which we are naming as a farmer field school, this we have constructed on an average at every 3,000 hectare in the field, where farmers can themselves see the benefit of scheduling, benefit of micro irrigation, benefit of pressurized irrigation, benefit of advanced irrigation tools like things, because in the farmer, what we have observed, they believe what they see. Seeing is believing for them. They don't read the papers and whatever literature we are sharing with them. To give them on-hand experience of micro irrigation, we have made this concept of use of demo form, where we are demonstrating the use of advanced irrigation tools like drone, etc., which are the nowadays used for the pesticide, insecticide, and latest cropping practice, which are there in the already in the world all around. Those things we are demonstrating in their field near to their farming land itself, so that they can get motivated and can adopt these things in the rest of the command area. These are some of the pics of demo form, like drip system, sprinkler system, mulching, and fertigation, which normally they are not using. That all those things are the features which is now possible when we are providing the pressurized water. So those things we are demonstrating in their field itself. Drone also we have demonstrated how best they can use for the pesticide and insecticide spray by without entering into their field, and through by sitting at the end of one end of the farming land, they can spray all the pesticide, insecticide, which reduce their dependency on the local labor hiring also. So these are the some of the uh, practical demonstration which we made in their field. So now, if all trainings, all things we have created the infrastructure, women is the another important factor which need to be addressed separately, because women in the village area or the remote area, they are not, women are not willing to come to our farmer service center, to our sometime to demo farms also. In the public, they are not coming. So, and no success can be achieved without female power, women power. So that part is also taken care. We have taken care that part, where we have recruited female trainers itself, who are conducting separate session for the women in their field itself, so that they can also get aware about this technique, and at a family level also they can also take a part in the decisions to go for the advanced things, so that it should not be only limited to the male community. So in that way, separate training programs has been conducted to get the acceptance from the female side also. Now, students, we have tried to cover this segment also through our study tour. We are regularly conducting this study tour of the school going children who are the future. And if for future we have to, like in the agriculture field, everything we have to sowing. So we are showing the culture of awareness and knowledge of the new techniques which are right now there and going to come in the future also. We are seeding them in the brain of school going children, who are the in future going to integrate this system with the new innovation of satellite and other advanced things which are going to come in the future. So they are also coming regularly to our project. We are briefing them. And if the students, Gen Z is the very fond for all these new techniques and softwares and all these type of without dependency on the human, whatever things are possible, they are the real catalyst who can trigger this in the society. So we are covering this segment through student knowledge. And then parallel, right now we are conducting global sharing session also, where one time Moroccan delegation has visited because they were planning to implement same type of pressurized micro irrigation network in their country. So they have visited. Then to get the international experts knowledge to our project, we have called ASC, American Society of Civil Engineers representative to our project, who has visited and shared their inputs also, which can be adopted in this project. And parallelly, some of the things of the project they also admired a lot. Then at the domestic level also, whichever states are now planning to implement such network, they are visiting our site. These are some of the delegation picks who are visited, which dominated by the farmers of that state. Gujarat, Maharashtra, Chhattisgarh state farmers already visited because they are in the advanced stage of implementing all this pressurized network in their country also. So these are some of the exposure visit. Farmers we are taking to the various Kisan Mela, farmer Mela exhibitions, where advanced tools are being demonstrated, which can be adopted in our project also. So whoever are the progressive farmers of the command area, we are taking them to the other exhibitions so that there they can also have the look and then adopt the thing and can motivate the rest of the farmers in their village for adopting, for quick adoption of new technique. So, so this what SDSR has also explained in earlier. We are as a L&T, we are part of irrigation network in the since last 20 years. We are in this field, and so far we have covered 13.84 lakh hectare area in different states of the country, where all type of at different stages. Somewhere we have constructed barrage, somewhere open canal, and nowadays everywhere pressurized pipe networks are coming. So, so this is the all about Kundalia irrigation project. Thank you all of you for a patience listening and giving us that opportunity where we are able to showcase our this project and this feature. And this knowledge need to be shared among the various platforms to get, because this is not the end of irrigation innovation. Lot of innovations are still needed in this field, because as earlier told, 89% of the water utilization in India is the irrigation. We have to increase the efficiency near to 100, then only we can save our future, because the food grains are the important thing which we can't ignore. And then all the each drop of the water shall be utilized for the more crop per drop. That is the mission of the government of India also. And same thing is needed from all the corners. We have to share the knowledge, because irrigation is not only a business. It is not at all business. It is a service to the society, which we have to make more effective. We have to give, and so that more yield of crop should become, along with the industrial growth and population growth, we can meet the need of the society. Thank you for all of you for patience listening. And now platform is open for question answer and any inputs which ICID wish to share with us. Thank you.
Thank you, Mr. Devanand, and thank you, Mr. Dinesh, for the very wonderful and elaborate presentation. I will request you to look into the chat box and question answer box. If you can see some questions, then please try to answer them.
Sure. I think a lot of questions were coming in between of the presentation also. So I will see that how much we can.
Yeah.
Just scrolling. So whether all the participants are able to see this chat box, so that, or shall I repeat the question and then answer?
You can read the question and then answer.
Yeah. So one question is related to the power consumption between power consumption, comparison of power consumption between open channel and this type of pressurized system. Yeah, it's a really a good question that normal consumption mindset is there. In the open canal, less power consumption is there, and this type of lift irrigation system involves more power. So just my view is that in open canal, when we are giving, okay, for the only we need the water for lifting and rest, farmers are taking water on their own. But how? They are taking the water from the canal also through their local motors and those things. By gravity, it is covering only the limited area. If to the tail end of the water, tail end of the canal, water has to go. They are using their own motor also, local power. Everyone is having the DB connection in their field. Here, once this system will be everywhere, no need of the power in their local power, which is normally LT power. Here, concentrated power we are using at our pumping system. That is the HT power system, where we have installed the modern tools of VFDs and then capacitor banks. Everything is there, which is controlling the power factor also and energy loss also. If you are using HT power, then power losses are comparatively less, which is there in the LT system. Over the period we are observing in our command area, which we have got from the power transmission department, their overall demand got reduced there. Of course, more power is needed initially, but if we are comparing this power per hectare of the command area, then it is absolutely in the order with the regular irrigation network also. And moreover, in that power, government is giving subsidies, and those things are there in there also, which are very well controlled through this type of lift irrigation system. Of
One
course,
more
our
thing,
command area
Dinesh,
should not be far away from the system. Yeah,
Dinesh,
yes, sir, you can add.
more, yes, in the isolation, if you are seeing the canal irrigation and the pressurized irrigation, yes, there is enough power consumption and sustainability. But when comparing the same slide, 275 hectares or whatever the water, now it is become 450 hectares, we are able to do it. The water, the value of water today, and the crop which is going to be create the values, the value which food material is going to make it, and it is going to give an opportunity to the farmer where because of its higher elevation he cannot able to do the farming. That value is there. When everything cannot be valued on isolation, but higher elevation we need to have a water, and the long term the product which is going to come, the ecology is going to help. This power cost is nothing. That is what we add. Even the same project, the first year, second year, third year, if you are seeing the power consumption also getting reduced, because the more awareness it is coming, the real cost of power is also reducing it. So here the system which we are using it, VFD and all, so the energy saving also it is happened. As and when it is required, you can do it. Wherever the crop knowledge is going to happen, there the consumption of power also going to be there less. Overall, if you are seeing the project, definitely it is going to be long run and sustainable. And every area we need to make the crop, then this cost is not. That is the way calculation it says.
Yeah, yes. Sir, next one question is there. Are all farmers aware of automatic irrigation? Yeah, that is thing which we are already told that more than 3,000 training programs has been conducted, and we are making at each OMS box one meeting where we are making awareness among the farmer and explaining about the feature of this automatic irrigation. So definitely adoption level is increasing year by year for the automatic irrigation. So then next question is there, how are farmer involved in managing water under this system? Yeah, that is there where I told that we are having everything controlled through the web SCADA. Farmers has to give only their water requirement when they need water. and they have to do nothing than that. They have to make a common agreement among the Chuck committee through Chuck committee at the 30-hectare Chuck level. Once they are making their schedule, our farmer relationship officers are there, FRO are there at every 500 hectare. They can communicate with them, and then rest of the things are managing through the farmer relationship officer, and scheduling can be done from anywhere. And another one more good question here: what can be a challenge of installing automatic irrigation in large area? The biggest challenge which we are seeing, if people are not getting involved in this scheme, then it is become a big challenge. Otherwise, once people are habitual of getting this water through automatic system without much efforts, they are supporting. This we have seen year by year. In the 3-year journey itself, now we are seeing that if farmer participations are there, we are not having much issue with the automatic irrigation. Initially, we were definitely having to maintain, to control all the vandalism and damage which were happening to the system. But year by year, it is getting improved to a lot.
There is a question now I'm seeing it 24 hours, we are managing it. Yes, since it is in a rotational basis and everything is pressurized irrigation, even any small misuse or even the repairs, we can able to see in the control room itself. So we are not facing such a issue that 24 hours, the program also made it for 24 hours because the rotational basis only we are providing water, and each crop, once the rotation start, minimum 6 to 8 hours water it is being given. So that is the way it is practiced, and it is we are possible, and we are making it also.
Yeah.
So it is not a big challenge of doing it 24 hours monitoring.
Yes, that I will like to add. Similar questions are there. How much pressure will get each OMS? That I explained that at each OMS we are providing inlet 25-meter water head, and then at every 1 hectare outlet it is 20 meter. Then coming to leak detection network, I already told that we are using this air management system, which is the additional checkpoint in the network. Otherwise, we are having the RMS, AMS, which are giving at the regular interval of the network pressure level. If any sudden drop is there in the pressure, we are getting the sense that some leakage are there. So their decision support system enabled in our SCADA to give us the alert. So with that only, it is helping us to maintain the 24-hour supply also. So that in night also, and another thing, if demand is reducing, that alert is also coming through the DC level, which is having 30-minute retention capacity. If DC level is increasing, we are coming to know that demand is reducing. And if DC level is reducing, means demand is more, we have to run more pump. In those way, decision support system is enabled in the automation network through SCADA, PLC and SCADA, which is helping us to control the working.
My only request is some of the languages we couldn't read and answer it. If it will take time, definitely all the questions will be answered, and we will coordinate with ICID and we will provide all the input. This is more knowledge, and even it is very good for using these precious water resources in a better manner for the better future.
And we are also sharing our email IDs with all of you, so that if any more suggestions are there from your end also, which can be integrated with this type of network, that is also welcome from all of you.
Thank you, Mr. Devanand. Thank you, Mr. Dinesh. I have a small question. Are you looking at the possibilities of increasing the use of solar energy in the system?
Yeah.
Here, solar energy being used for all our communication systems where it need a power. Another more challenge is there. Everywhere we cannot able to give the regular power supply. So we are using solar, yes, wherever for the communication purpose. Since the capacity of the pump and other things, it is need a huge power supply, and the capacity with the solar, it is not feasible for doing it.
Yeah.
Moreover, it is all maximum rainy season. We no need of giving a water, where non-rainy season, the project has been Rabi season, where we are talking about 6 months effectively we are giving the water. So that is the way the cost and the things it is matching. Because
And
you need a huge higher capacity motors, it is very difficult to use the
so,
power supply for the main pumping.
I will also like to add, but there is another opportunity at the reservoir level where solar energy can be generated by floating solar panel over the reservoir. That is nowadays being already projects has been launched in India for this purpose also, because reservoir is having a big catchment area where already water is there. So floating solar panels are being used, but it will add water to the system, not for this type of running the pump, because here local power requirement is more and we can't depend totally on the solar energy. So that is the thing. But definitely reservoir efficiency can be improved by using solar panel over that, which will add to the grid.
Thank you, Mr. Dinesh, Mr. Devanand. President, do you want to say something?
Well, no, actually, I'm very impressed by the presentation that have been given, and I can only be very, very happy and very, as I said before, very proud for the high level of contribution that have been brought today here at this nice webinar. So I think we are on a very fruitful pathway. And so I really want to warmly thank Mr. Dinesh Karbanda and Mr. Devanand for the excellent contribution, the excellent knowledge sharing they have brought to us as ICID community, but also to the hundreds and hundreds of people who have been participating to this webinar. I can see from my side, but you can also see there's a lot of requests for sharing presentation, lots of questions. So I'm very, very happy. Really, I'm very grateful to you. Thank you very much.
Thank
Yeah.
you.
Thank you,
President.
to all
I
the
think the presentation going to be shared, Nazar. That is what so many people are
ICID.
asking. That from ICID, if you are informing, it is good for all the participants.
we will be putting up this presentation and the record of this webinar at our website, and this will be available at our website by tomorrow. By tomorrow afternoon.
And of course, if I may say just one last thing, of course, you are right away, you are invited, you are mostly welcome to join us. I think Secretary General will also speak a little bit about this to our in the Water Summit, which is going to take place in Delhi, New Delhi, in June. So, Secretary General, I would be very happy to meet you personally. Please, you're invited. Thank you.
Yes, we have already invited L&T. They are our very big partner, and we have requested them to give technical presentations, to have exhibitions, to participate in exhibitions, etc. And I also again request Mr. Devanand, Mr. Dinesh, all to join Indo-Global Summit in June. And it will be very nice to have you all there. So we will be sent. We have already sent the invitations, but we will be requesting you again.
Sure, sir. We will be. Even last year we've been there. This year also we will be there. We'll continue our contribution to the ICID will be there. Thank you.
And we will also look into the opportunity of visiting your project sometime.
Yes.
But we were planning earlier to visit at the end of our global summit in June end, but it will be too hot to go there. So we dropped this idea. So
maybe Secretary General, maybe during India Water Week, hopefully, maybe there's another opportunity.
Yes, so in October or November, so it will be a good time to go there. So we will plan accordingly.
Yeah, we can show some other projects where challenging projects where we are higher elevation, we are pumping and providing water. That is also we can able to showcase to you. Most welcome.
Thank you. Thanks.
My final, I want to make, sorry, Secretary General, just a final remark. My idea is that what we have seen today, not only today, there is not, the world has been changing, but the world has changed and it's keep on changing. So there is no anymore north, south, east, west. what we have to strive for is to work to get this planet, this world better, whatever the contribution is coming from. And this is an excellent example of how the world is changing and keeps on changing in a very, very positive way. So I'm very happy. Again, thank you very much for this excellent contribution. I can see from the comments the people are enthusiastic. So again, thank you very much. And thank also to the people from Central Office, my colleagues, coordinated by Secretary General in an excellent manner. Thank you.
Thank you, sir.
Thank you, President. And thank you all the presenters once again. And thank you all the participants who have joined this webinar. I request all the participants to participate in our next webinar also, which is on 22nd of May at the same time. See you on 22nd of May. Thank you.
Thank you.
Thank you.
Thank you. Bye-bye. See you soon.
Thank you.